Hello everyone, my name is Sunil. I'm the project manager of the Solar Car team. Next slide please. These are the objectives that we'll be going over during the presentation. Next slide please. To start off with our background, the FSGP is a qualifying race for the American Solar Challenge held every summer. And the American Solar Challenge is a 1,500 to 2,000 mile endurance race held every 2 years, and the only power that we're allowed to use is the sun. Now why are we doing this? Solar energy is the most abundant renewable energy source on planet Earth. It is also California's leading renewable energy source going into the foreseeable future. Next slide, please. Now for our system breakdown, we have 9 sub-teams and we have a total of 33 members. Next slide, please. Our overall goal is to design and manufacture a functional solar car. That to compete in the FSGP 2021 and ASC 2022. And what we want to focus on is low cost, safety, and efficiency. Now for the academic year 2019 to 2020, we want to focus on completing the design of the entire solar car, the manufacture of the mechanical portion, choose an encapsulation method, and make sure that all the electrical systems are properly tested and validated. Next slide, please. When it comes to the design requirements on the mechanical side, the chassis system must sustain 5G loads on all points. The suspension system must sustain 4G combined loads, 2G bump, 1G brake, 1G turn, and the aero body must have a low coefficient of drag while also providing 4 squared meters of room for the solar array. On the electrical side, the safety system must shut off the vehicle in any event of failure. The battery and the solar array are the only sources of power we're allowed, and the vehicle must also have a telemetry system to collect critical data. Next slide, please. Now here's our timeline for the entire year. Now just for this quarter, on the mechanical portion, we will be creating an initial CAD design for all the components of the car. For the electrical side, we'll be designing all the electrical systems, and then moving on to next quarter, we'll be testing and validating those electrical systems. Now I'll be handing it off to our mechanical lead, Thomas Slagle.
Alright, hello everyone, my name is Thomas Slagle and I'm the mechanical lead for the UCI Solar Car team. So on this slide I'm going to be talking about all of the accomplishments that we've done this quarter. So I'm going to start off by talking about the aerodynamics sub-team. So they've completed the aero body model as well as contacted companies for canopy quotes. Now we're contacting other companies for canopy quotes because the top surface and side surfaces of the aero body will be made in-house by us. However, we do not currently have the means to manufacture a canopy. We've never worked with fiberglass before, so we'll be using an outside vendor to make that for us. Next, we'll be talking about the chassis sub-team. So the chassis sub-team completed the chassis model, and in addition to that, created mounting for all components completed. In addition to that, for the chassis model, they made black boxes for all the individual sub-team components that will be inside and outside the chassis to make sure that everything fit. Next, the human interface sub-team, so they finalized the steering and braking subsystems, and in addition to that, created a human wireframe driver model for our chief driver. This wireframe model will help us with sizing of components and making sure that everything actually fits and with the driver. In addition to that, we can use the wireframe model to simulate the driver's weight in the car. Lastly, we have the suspension sub-team. So the suspension sub-team finalized the front and the rear suspension. For the front and rear suspension, they're going to be bought off the shelf. The reason for that is they're tried and true, and we're using OC Honda as our vendor, and one of our advisors gets discounts from OC Honda. So this will help us with cost, timelines, and just overall efficiency. Now the front and the non-driven rear wheel will be utilizing the TRX 250X ATV front suspension, and the rear wheel will be using the Rancher 4 tracks for the rear driven wheel again. Next slide, please. So now I'll be going a little bit about the mechanical breakdown. So on the figure to the left, we can see a wireframe model of the mechanical CAD. So in this model, we have the aero body, the chassis, and the 4 wheels. This is the model that we're going to be building off as we go into next quarter, as we start taking all the individual sub-team components and sub-assemblies and integrating them together. Next, we have figure 2 on the right. We can see these nice isometric streamlines moving over the car, and this is one of our main simulation results that was gotten in ANSYS. Next slide, please. So for the mechanical next steps, so again, moving in the next quarter, we're looking to accomplish full mechanical CAD integration. Next, we're going to be looking into making the entire car lighter while keeping the same base design. So originally our goal was to have the chassis to be under 100 pounds because our last chassis that we built was super overbuilt and we don't want to make the same mistake again. Right now, the chassis design that we have is utilizing 1-inch round steel tubing which is about half the diameter as our last chassis and is about half the weight. However, it's still a little bit too heavy. It's about 140 pounds. So we're thinking about switching the chassis to aluminum, and that should save about 50% of the weight. So it should be about 70 to 80 pounds. Next, we're going to be doing full design validation, so making sure all of our sim results are solid and meet the ASC regulations. And lastly, towards the end of the quarter, we are looking to manufacture our chassis. So next, I'm going to be handing it off to Gilbert to talk about the electrical progress. Thank you.
Hi, my name is Gilbert and I'm the electrical lead. So this quarter we focused on three major things. The first of which is our low voltage system. So this system provides a way for the driver to shut down the vehicle in the case of a failure, which is important because it will keep them safe if that were to happen. The second thing it does is that it provides power to our transmission control unit. So this is an onboard computer that provides driver with functionalities such as park, drive, neutral and reverse, as you would find in a normal car. The second major item that we focused on this quarter was our telemetry system. So this system is responsible for measuring data all across the vehicle, which is important to making sure that it is healthy or not. So, for example, if the motor were to undergo failure, our telemetry system would allow us to diagnose that issue. The second item that we focused on this quarter is our high voltage system. So our high voltage system is composed of three major components: the motor, the solar array, and the battery. So this quarter we focused on figuring out a way to encapsulate the solar array, since it will be placed on the aero body and needs to be protected. And the second thing that we focused on is the battery enclosure. So this is responsible for isolating the battery insulating the battery and for keeping it under optimal thermal conditions. Next slide, please. So shown here is a block diagram of our low voltage system. As I said before, this is responsible for shutting down the vehicle. Next quarter, the plan is to buy components, not the actual components that will go in the car, but cheaper components that we could easily get rid of if they show to not work, and to test basically the entire functionality of the low voltage system. Shown on the right is a block diagram of our SQL database. So to go into more detail, this will basically be a cloud system responsible for showing all that telemetry data that I was talking about. So when the driver needs to access data, basically he will interact with the SQL database to retrieve that data. And this is basically how it works. Now I'll hand it off to Subin, who will wrap up this presentation for you.
Hello everyone, it's me Subin. I'm here to wrap things up for the end of this presentation. For our achievements this quarter, we created the initial individual designs for all our CAD components of the car, and we also created the initial low voltage system designs. For our next step, we plan on creating the CAD assembly of all parts of the car. We also plan on testing all the electrical systems, and then we're going to move into manufacturing the actual car. Thank you for watching this video, and I hope you have a great day.